what this is saying is if you have a tangent line is drawn outside a circle, only touches once. What that's saying is if you have a radius touching it, they're going to be perpendicular. So it's going to make 90-degree angles. That is half of what we're going to be doing. So that will help us find these angles down here. So if they give me 38 here, they're asking for this angle, radius, tangent line, 90 degrees right there. Okay, so if you've got a tangent and a radius, they make a 90-degree angle. So all you have to do for this one is simply subtract from 180. So all that's going to give you is 52 degrees for your angle X in that one. Okay, I've got a lot of examples to show you today. These are the ones that are a little bit more tricky. So you have a right triangle in there. They give you a radius. All the radii are equal. So both of those are X. And to be able to do the Pythagorean theorem for this, you're going to have to do a squared and b squared equals. And then I need to get this entire segment, which will be X plus 8 squared. We saw that a little bit last week. So this is X squared. This is 144. And I had a lot of people mess up this foiling because we leave out the middle term all the time. So when you do this, it's X times X, it's X times 8, and then it's 8 times X, and 8 times 8. A lot of people want to leave out this stuff in the middle. You can't do that. Okay, so this will give you 16X and 64. So when you do this, for the most part for these, you are just going to get these to cancel. Later, we might have to factor to be able to solve. So if those kind of things don't go away, you have to factor to solve, which is really annoying. So hopefully we won't have to worry about that. Usually you don't. So if I subtract, that's going to give me 80. And then if I divide by 16, I think that's 5. Yes, that's 5. So they asked you for the radius. X is your radius. So 5 is your answer for that one. Okay? So I gave you another one because I did that really fast. So this is the same thing. If they leave out this X right here, you have to assume that that's going to be X. All radii are equal. Okay? So in this case, I've got a squared and b squared, which is your X and your 10. Equals, and this whole thing is X plus 6. So if you square that, you're going to get X squared and 12X and 36. This side is X squared and 100. So those go away. If I subtract the 36 from both sides, that's going to give me 64. And then if I divide by 12, that's 5 point something, I think. 60. 5 times 12 is 60. And then 5.8, I believe. Okay, so 5.8 is your X. That's what they're asking for, is your radius right there. Okay, so next, this says identifying a tangent. I'm not sure if you'll see these or not, but I wanted to put that in there in case you see them on SOLs or if you see them on SATs, and ACTs. So I don't think they're on your homework, but I wanted to throw them in there. So it's asking you if ML is tangent. So they're wanting to know basically, is that a right angle? Because for ML to be a tangent, it needs to have a right angle right there. So they're asking you, is that a right triangle, basically? Now, what I want to show you is this 25. This 25 is assumed to be the entire line because it's right in the middle of it. If your 25 was out here, then you would say that would mean that this is 25, and then you'd have to add another 7. So placement of your numbers is important. It's in the middle of the line it's supposed to be at. So right here, this whole thing would be 32. But if this is sitting right here, that is for you to assume that the whole thing is 25. So to figure out whether or not that's a right triangle, you are going to do a squared and b squared and see if it equals c squared. If it equals it, then you're good. If it doesn't equal it, then it is not a right triangle and your line is not tangent. So I've got 47 squared and 24 squared. Hold on, sorry. Which is going to give you 625. So that does work. So this is 625. 25 squared is also 625. So this works. So is it tangent? You would say yes. And to explain, you can tell me that I've heard some of you guys say this is a Pythagorean triple. That's fine. You can say the numbers work in the Pythagorean theorem. That's okay. I'll even accept the numbers as an explanation as long as you show me somehow you know that it is a right triangle. So another option would be to say segment ML, excuse me, is perpendicular to segment LM. That's probably the shortest way to explain it. Okay? Sorry, what's wrong with me? Allergies. All right, now in this one, at the end, I'm going to show you on your circles the pink part, because if you have two tangent lines that intersect outside of a circle like this, that means they're going to be the same distance to the circle. So that's the part that I'm going to give you in the circles at the end. I put this in here because if you have a line drawn to the center of the circle, it's going to cut angles in half. So it's going to cut these two angles in half, and it's going to cut those two angles in half. Again, I'm not sure how much you're going to see it, so I just want to give you that info as well. So the rest of this whole section is just some examples. Some of them are much shorter than others. So for this first one, see how the 9 is only in between here? That means this is also another radius, so this is 8. So when you do, and I'm not going to work out the Pythagorean theorem, I'm just going to set it up because you guys can do the Pythagorean part. So this would be 8 squared and x squared equals, and this would be 17 squared. So you have to pay attention to the placement, keeping in mind that all radii are equal. So even though they didn't give me that, I knew it was 8 because they're both a radii. Over here, this is just showing what I was showing right up above, where if you have two tangent lines that are crossing and their distance to the circle is going to be the same. So this is just 12. Over here, you got to do a little bit more work. Notice your tangent lines. If they're intersecting with a radius, that's going to make them a right angle. Okay, now I've got x, I've got 8. Notice it's only in between this. So that means if this is 5, then this is 5. So, excuse me, to solve for x, also this is 5. To solve for x, I've got a squared and b squared. And then I'm going to equal 13 squared for that one. Okay, next over here with these, of course, that would, this right here would be a 30 as well. But what I'm going to do is I'm going to go from here to here, because what that's going to help me with is I'm going from the center of a circle to the tangent line. So a radius and a tangent are going to make a right angle. And they told me that just from here to here is 40. So to solve, this is 30. This is also a radius, so it's 30. You would have to do a squared and b squared equals, and then you would have to do x, that's a terrible x, plus 30 squared, because that's this entire line for your hypotenuse, x plus 30. Okay, over here, the 8 is just attached to this, so you'd have to add 8 and 21 for that one. So x squared, 21 squared is equal to 29 squared, because I added them. Okay, that next one over here, this is showing you two tangent lines. So that's 6 and this is 6. Two tangent lines intersecting outside a circle here, 12 and 12. Same thing here, so 8 and 8. Usually what they're going to ask you for is they're going to ask you for the perimeter of the triangle. So you'd have to know those numbers and just add them all up. So 12, 12, 6, 6, 8, and 8 equals whatever. So that, you'll see that as well. Okay, these two, same idea. Now we're just solving for x for this one. Two tangent lines intersecting outside the circle, 2 and 2. Same thing here, 6 and 6. And same thing here, 4 and 4. So to get x, you just have to add up 6 and 4 to get 10. Okay? You don't need all these examples in your notes. They were just for me to show you so you understood how to do most of them. All right, this is 4 for a radius. So all of these radii in here are 4. Okay? Then I have this part. They're saying just this part is x. So if I've got a tangent line and a radius, there's my 90-degree angle. Okay? And then we need to figure out what this part is. I think, oh, okay. So this is the important part that I couldn't see because of my picture. If it's equilateral, that means all three angles are 60. And what I showed you above was if you had a line from the center, it's going to cut it in half. So these are now 30s, 30s, and 30s, which you really only need to do it once. So if you want to take this triangle And you now have a 30, 60, 90 degree triangle in here. So this is from old stuff when we had special right triangles. This was your Z, and then across from your hypotenuse is 2Z, across from 60 is Z squared root of 3. So if they're asking you just for this X, first of all, I got to get 2Z. So I got to do 2 times 4, which is 8. Now that's the total side. So I got to get rid of this 4. So this X that we're looking for is actually going to be 4. So you have to pay attention to little things like that. Otherwise, we wouldn't have been able to solve that. Okay, and then the last two are much more challenging, but I wanted to throw them in here because, again, these are good SAT questions. So the measure of an angle formed by two tangents, I made an image right here. So an angle, this angle right here formed by these two tangents, they told me was 90 degrees. So I'm going to put a little box in there. And then it says the radius of the circle is 8 centimeters. So if I do this radius right here, that whole thing is 8. So I'm going to make it a different color just so that we remember that. Okay, so that blue part right there is going to be 8. I'll underline it so we don't forget. How far is the vertex from the angle from the center of the circle? So the other thing they're talking about is they're talking this vertex right here. So they want to know how far the vertex is. I colored it wrong. Hold on. So the whole thing got colored, but just the blue part is 8. So they're wanting to know how far is the vertex angle from the center. So it's the blue and the black combined. That's kind of what we're looking at. So to be able to do that, I can't bring my thing over here. Okay, so here we go. So I'm going to connect this right here, which is also going to be blue because it's also going to be 8. So that part, that didn't work for some reason, whatever. So this radius is 8, this is 8, and we don't know what that part is right there. So it says the radius of the circle is 8 centimeters. How far is the vertex? So we're looking for the 8 plus x right here is what we're looking for, okay? So in that case, this right here, I've got a 90-degree angle because this is a radius and this is a tangent line. So remember that when the radius is connected to that, it's cutting it in half. So these are 45s. And then you can use your 45, 45, 90. So again, this is a special right triangle. So across from your across from your 90-degree angle is your hypotenuse. So that is square root of 2z. And these are my z's. So if I'm looking for this, 2z is 2 times, or square root of 2 times 8, which is just this. So that's going to be my entire thing. So I need to, and that's pretty much it. So that's what they were looking for. So you didn't really have to solve for this little piece of x. They just wanted the entire thing, which we just found. If you had to find the little piece of x, you would just subtract 8 from whatever decimal this is. So those are tricky. This one, the reason why I left this one in here is because I wanted you to know this word, because this is another big ACT, SAT word. So it says the triangle is circumscribed about. So before we had inscribed, and inscribed meant like the circle is usually inscribed would be like this. So this is when a triangle is inscribed in a circle. So inscribed means inside. If it says circumscribed, that means the circle is the one that's touching the triangle. So the circle is, or the triangle would be outside in that case. Okay, so I just want to make sure you know that vocab word. They put big words like that and people don't know them. So circumscribed means the triangle's on the outside instead of on the inside. So it says GH is 20, so this entire thing is 20. HI is 14, and IG is 12. It says find the length of each segment whose endpoints are G and points of tangency are GH. So what they're basically talking about is they want to know this one and they want to know this one. Okay, that's what they're asking. So knowing these are both going to be the same because I've got tangent. So those are equal, these are equal, and those are equal, but not all equal to each other necessarily. Okay, so my best guess would be to, my best idea would be to guess and check. So I need two things to add up to 20. This one needs to be less than 14 because you can't have 14 and 14 and then have 0. This one needs to be less than 12 because if this is 12, that would have to be 12 and that would leave nothing. So it has to be less than 12. Let's just say we started with tens. So if you did tens, then 20 minus 10 is 10. This would have to be 10. And if this is 14, that would make this 4. And this would have to be 4. So if you did 12 minus 4, you'd get 8. So that doesn't work. Okay, so you might be able to use some triangles to figure it out more formally, but I think that's pretty, the guess and check is pretty sufficient on this. So if I go with 9, let's say I go with 9. If I do that, these are, reverse. If I do that, 20 minus 9 is 11. So this has to be 11. 14 minus 11 is 3. And 12 minus 3 gives me 9. So these work. I knew I had to go smaller because this one was too big last time. So I just went 1 down. So that's what we'd be looking for. Your answer for this one is just 9 units. Okay. Now, for your examples, I've got some examples here. That way, if you want to try any and you can pause, I think I give you the answer key for the evens. So those are the evens if you want to practice any extra in addition to some of your worksheet that you'll be having. Okay, so let's go back to this. I'm going to add one. This one is already done. For the angles, we're done. We have all the angle rules. So what we have left are segment rules. Today, we're going to do the tangent ones. Tomorrow, we'll have secant ones. So right here, you can throw tangent in here. So the two things I wanted to add for tangents was the ones on the outside and about the 90-degree angle. So let me make sure I give you all the right stuff. So the one I did was this tangent coming from the center of the circle, and that's going to make a 90-degree angle. So let's add that one today. So radius, I'm just going to put a radius and tangent are perpendicular. Okay, and then for your other one, that is when you have two tangents like this that intersect outside. And all that means is these two are equal here. Okay, so two intersecting tangents, it's technically outside the circle. So two intersecting tangents that are outside of the circle. If you have that, then from the points to the intersections, so from the vertex to the intersection, are equal. And you just kind of translate it, whatever works for you and whatever wording you understand. I just try to make it as short and sweet as possible. But if you need to write more or change it up, you can. Okay, so that's all I was going to have for today's circle. If you want to add in there, where if you have this, you might want to add this in there where these will be congruent and those will be congruent.